MOISE is a collaborative project conducted by the IRT Saint Exupéry, focused on the aerospace domain. It brings together industrial companies, consulting firms, tool vendors and public research institutes around a common goal, to develop collaborative model-based approaches for system engineering in the extended enterprise. When developing complex systems, partners of the extended enterprise have to exchange and process tons of engineering data, most of which in a text format. Through a greater use of models, the project aimed at improving the efficiency of information sharing between companies and across engineering domains. By providing means to achieve seamless co-engineering, we help reducing misunderstandings, design iterations, and ultimately development costs. The project tackled 4 thematics. 1. How to exchange and aggregate heterogeneous modeling data across the extended enterprise. 2. Ensuring consistency between safety analysis and system definition models. 3. Generation of a co-simulation environment based on the system architecture description. 4. Improvement of the need elicitation using models in a customer-supplier relationship. The development of a new aircraft goes through many steps. First, following a call for tenders, the aircraft manufacturer selects the system suppliers. Together, they form the extended enterprise. According to their work sharing, they collaborate to design highly integrated and complex systems. Then, those systems are manufactured and undergoes many tests. They eventually get the clearance for first flight from the airworthiness authorities. Then, the aircraft can leave the ground for the very first time. Beyond this idealistic vision of a straightforward development process, let's recall that real projects follow a highly iterative path with high financial stakes. All along the project, unexpected events such as specification changes may occur. Some of these can lead to review the initial proposal and require adaptations of other systems. Then, the development starts again, until another unexpected event occurs, such as the detection of integration problems during the tests leading, for example, to modify the system interfaces, and so on, until the completion of the development. MOISE project aims at reducing the number of iterations, by ensuring that the initial specification covers the needs, and by defining and specifying the system context. More precisely, we studied how to ease the collaboration and the technical convergence between partners during the call for tenders. We defined and validated a method to improve the mutual understanding, allowing a complete, correct and non-ambiguous need elicitation, while avoiding excessive specification that could narrow the range of solutions. Usually, during call for tenders, the aircraft manufacturer sends a technical specification of the expected system to its supplier, who answers by a preliminary technical proposal that possibly leads to a specification update. Often, a great deal of effort is put to define a solution, even though system context and needs are not fully described nor understood. Our method proposes 2 main improvements. The first one is the introduction of a preliminary step for sharing the problem. System context and needs are described before defining a solution. This new step is integrated in a consistent collaborative architecture definition process. The second improvement consists in enhancing the efficiency of the technical exchanges by using models and viewpoints for system context definition. For instance, the list of systems and actors in interaction with the system. The interactions of the system with its environment. The system detailed external interfaces, the life cycle of the system, the aircraft functions relying on the system, the scenarios describing the exchanges with the system environment. This step allows to share the system context, and then to consolidate the main system needs. MOISE method derives from 2 existing system engineering methods, CSIM operational analysis and Arcadia system need analysis. It defines a set of viewpoints adapted to the description of the context of aeronautical systems. It describes how to analyze context and needs. And it also includes guidelines to analyze the customer technical specification and to prepare a customer-supplier review. We have successfully modeled the MOISE viewpoints in Capella, and tested the scalability up to an avionics system. In collaboration with Liebherr specialists, we also have tested and perfected the full methodology, including customer review and modeling techniques, using a real industrial study case, a bleed air system. MOISE project also produced transverse outcomes that supported our activities. A study case of a drone for aircraft pre-flight inspection. It is composed of architecture models, safety models and behavioral simulation models, some of which are open source and can be downloaded from the IRT Saint Exupéry Forge. A glossary, or more precisely an ontology for more than 300 terms relating to system engineering, constituting a valuable common reference. And is part of our state-of-the-art review is structured databases of 230 ID cards for MBSE methods, languages and tools that can be accessed online by our project members. Thank you for your interest, and do not hesitate to contact us for further information.